It's my pleasure to restart our content here on the main stage. We now are entering the XR enablement track here on the main stage at AWE Asia. So when we say XR enablement, this refers to quite a lot of things. We're talking about both the components, the underlying technology, inputs, as well as software that enables the next generation of XR technology. So to begin our sessions here on the main stage in the XR enablement track, it's my pleasure to introduce Mr. Andy Lin, who is the Vice President of Sales and Partnerships for the APAC region from Dispelix. And it will be presenting the session Perfecting Comfort, the vision behind Dispelix's waveguide combiners for near-to-eye XR displays. Please join me in welcoming Mr. Andy Lin.
Thank you. Good morning, everybody. Thank you for the time for the presentation. It's really exciting to be here. Nothing excites me more to be with the crowd in an event of AR enthusiastic, especially in a beautiful city like this. So today, we want to talk about perfecting comfort on augmented glasses. It sounds like such a simple request, but why does it take a sophisticated technology to achieve that? So I'd like to start by introducing our company, and we'll go take you through the technology and what are some of the key elements that it requires to achieve that comfort. So Dispelix is a cutting-edge diffractive waveguide company. We design, develop, and manufacture waveguides. We are a fabless company, which means the manufacturings are done through our partners. We are founded in 2015, and we are located in Finland. We have offices in US, in China, that is fully owned by Dispelix. Currently, we have about 150 employees, which about 60% of our colleagues are PhD, and they are from 35 different countries. What that means is that in this field of technology, it requires expert knowledge. So we are willing to look everywhere for the right talents to join our company to deliver the technology. We're highly innovative, so we have 150 patents filed, and we have 200 plus more that's filing. So what is our mission? I would like to steal a line from the AW president already yesterday. So the XR device should be wearable by everyone, everywhere, all the time. And our concept, our mission is based on that very similar message. What does it take for augmented reality glass to reach the consumer market? And we believe, as many of our partner and customer, as many of you sitting here, we would agree that for consumer to really have augmented glasses, that requires something that looks like just like a regular pair of glasses I'm wearing right now. So that is our mission, is to deliver that key components and to work with some of the device creator, maker, manufacturer to deliver that solution to the market. So here's a picture, our vision of what I just mentioned about. So what our vision really created our mission. And our mission is where we focus on the technology development. So in this glass you're looking at here is the augmented reality glass we believe that reach consumer market. That is stylish, that is lightweight, and that will be able to be worn all day and with a great picture of visual comfort. So what does it really take to define a product? Of course, a product goes beyond just the display. So looking at the picture here, that will kind of define what an augmented reality glass product will be. Depends on the user case, user scenario. These are some of the key features that could implement into the augmented reality glasses. Other than the key display here, some customer might want to do untethered, wireless connected to a phone, to a device, to a computer. Some customers, some developers, some creators, they say, hey, we want more function. We like to have certain sensor, such as 6-DoF sensor, such as eye tracking, such as hand gesture. A lot of people talk about if you're wearing augmented reality glasses, you got to be able to control things. You got to be able to put things with your hand gesture. So that's very important with the sensor. Also, some developers believe that computing chips to implement it directly into the glass. So that would what define a product here. And of course, one key thing that often comes up is the prescription. Many of you here in the audience wear glasses, myself as well. So we need to have that solution to have prescription lenses into the AR glasses. So for Dispelix, we start by research the best methods of delivering the products to the market. So by that, now we're starting from whether it's software from advanced algorithm or to diffractive surface relief grating. So in a nutshell, diffractive surface relief grating is implementing nanostructure in high reflected index glasses that allows to transfer light from the input pupil area and that directs to the eye box area. So we focus on full color, single layer. So single layer that looks just like the regular optical lenses. And our application goes from wearable, near eye wearable, just glasses, or to head-up display, whether it's for auto, aviation, or marine purposes. And we continue our research with new geometrical methods, new material, just a new manufacturing process, just to ensure we bring the cutting-edge technology and innovation to the market. So design is the one thing that we focus on. We have proprietary simulation software with graphical user interface. These converges to convention algorithm with AI features. And we design waveguides for LED and laser. What that means is LED light source and laser light source. By LED light source, we're referring to display technology like DLP, LCOS, and micro LED. And laser, simply that will be a laser-based scanning technology. So here's the three key directions we do with our product. We have a standard product. Standard product that allows our customer to quickly take our waveguides and to integrate with the projection technology that they prefer or that's suitable for their use case, user scenario, and that can quickly divide and develop a device based on. And since our waveguides are produced on a glass wafer, and when all is done through laser cutting, so we can do some customization based on our standard waveguides. Customer can do the shape and form factor that we prefer. One thing that we're specialized is the fully customized product. So we're gonna have a customer come to us with specific user case, user scenario, that we can design a waveguide specific for that purposes. And we have done many customized design, whether it's the large field of view, up to 90 degrees field of view with ultra efficiency. And these are some of the track records we have done on the customization. So when it comes to customization, and we will talk about how to work with customer to reach the right solution. And as many of you here are expert, and we know in the optic physics world, there's also some interdependency that we have to look at when we're designing waveguides. Here's some examples of looking at these design interdependencies. Okay, if you want something brighter, if you want a bright device, that automatically means you need higher output from the projection. What that would mean is you have to compromise on the battery life. There's going to be a thermal issue, the heat issue that we have to deal with. If you are looking for higher brightness, you might have to compromise some on the field of view. You are projecting the same image towards the larger field of view. Of course, you're going to lose some efficiency towards that. So when there's a field of view, if you want to reach a field of view, you have to start thinking about the compromise on the eye relief. Eye relief is referring to your eye distance between your eyes and to the glasses. And of course, eye box is an important factor. I'll explain more on why eye box is so important on the later on pages, and that is just key critical parts when you're designing augmented reality glasses. So there's some of the interdependency that you'll be looking at through these where we're designing waveguides. So having that capability to design and develop waveguides not requires the right expert, but also the right tool. And we have this in-house designed waveguide studio that does just that. So we use linear and double periodic grading with all possible propagation directions. We use field propagation compared to the traditional ray tracing, which is about 20,000 times compared to the ray tracing. And of course, we can do grating structure both on surface relief grating and volume holographic grating. And of course, we can do double side grating and multi-play design as well. And one thing that's very important for these software is the speed and the consistency during design and development plays. And not just consistent and not just speed, but also the accuracy of the software. Because, and I'm very proud to share that we have a great track record from simulation to actual physical sample in the past. And of course, the MTF optimization and tolerancing, and these are all compatible with high-performance computer clusters. So having design, development is great, but it doesn't take us to the mass market. What does it take to the mass production if you don't have a feasibility for manufacturing? It's not going to hit the consumer market if you don't have a feasibility on manufacturing. So our approach relies on standard semiconductor manufacturing process. So these technology are already done on a high reflecting index organic materials. These tools already exist. These processes already exist. And we work with manufacturers like Applied Material and AAC. And these are large companies, so that tells you that they have the capability for manufacturing. So we do direct etching, ensure the high structural fidelity and easy pathway to complex grating shape, such as slant. Slant is like the slant grating, okay? And we have design freedom with high reflect index materials with ideal grating responses. So what it does is we have this mature technology that will reach high yield rate. And that comes with cost benefit. And that's very important to have something to launch in the consumer electronic market, is to have that mature technology, consistent production, and even the capability to expand the production line when it's needed. Okay. So our production, of course, the way we put the manufacturing is compatible with contactless lithography and nano imprint lithography. And manufacturing, one last thing before we go into more about the comfort thing. After manufacturing, there's only one key part in the technology development. That is metrology. You gotta be able to measure. You gotta be able to verify. You gotta be able to validate the product. And we work with various metrology tool companies in the industry delivering that from the design phase. So from design phase, we need to do verification, validation, and of course, during the manufacturing process, it's very important, where it's the inline and end of line. And we control the optical dimension and parameters. Now, to the key point. We're talking about perfecting comfort on the augmented reality glasses. So what are some of the key elements here that we're looking at? First is the social comfort. Second will be the wearable comfort. And third will be visual comfort. Starting with social comfort. So when we wear a pair of glasses, what does it mean if we want to go inside, whether it's indoor and outdoor? It needs to look natural. when you wear a pair of glasses, you gotta be able to have great transparency looking out. At the same time, it has to have a clear picture. And I've always tell everybody when it comes to social comfort, it goes beyond just the user. It goes the opposite person that's sitting across from you. Because when you're wearing these glasses, the other person got to be able to see your eyes. They got to maintain the eye contact. So the glasses, the augmented glasses, cannot have light glow that comes down. They cannot have the content that you're looking at. It looks natural. And also, our design integrates certain design pentascopic tilt and wrap into it. What does that mean? None of our glasses are perfectly perpendicular from the arms to the lens. We all have that little pentascopic tilt and frame wrap that give you a better design and style. And that is something very important for consumer. None of us wants to wear a bulky, hideous-looking glasses when we go out. So eye contact, important, privacy, these are the key points for the social comfort. And wearable comfort, that means lightweight. Of course, lightweights are very essential to this. But not just lightweight, not just thin, not just lightweight, but how do you achieve that balance on your glasses? There are certain display solutions in the industry today. They are lightweight, but it doesn't have that balance when you wear them. Some of them, the front torso is a little heavier. So that balance is very important. And eye relief, we talked about eye relief. The eyes and the lenses need to have that comfortable distance. Additional, we talked about prescription earlier. You got to have that space to be able to implement prescription lenses into the glasses. Of course, it's comfortable to wear, it's good looking, but it is augmented reality glasses. So visual experience is extremely important when it comes to augmented reality glasses. So eye box, we mentioned about it earlier about the eye box comfort. Why is it important to have large eye box? I believe most of us have the experience of using a binocular telescope before. I'm sure we all have used that before. And I don't know if you remember, whenever you're looking through these binocular telescope, the eye box is really small. So they have a hinge to adjust the IPD, the interpupil distance. And that's because the eye box is so small, so whenever your eyes are not within the eye box, the image gets cut off. But with diffractive waveguides, without diffractive waveguide, the large eye box makes it very comfortable to wear. If you ever experienced it before, as soon as you put the glasses on, you see the full view. And it feels so natural. It doesn't feel like you're looking through a tunnel. It looks just like an immersive view as soon as you put it on. And the large eye box really plays an important role of that. The brightness level, many of us would want to take it outside, whether for the indoor use or outdoor use. These are very important when it comes to visual experience. Then, of course, if you're going to wear augmented glasses, often you're going to be able to read text clearly. You want to be able to read things coming in clearly. So that sharpness of visual experience is very important. So here's just a quick look of our product, Dispelix Silver. This is a standard product. This can cover from 30 degrees to 50 degrees field of view. It's the same product. It depends on the projection technology you choose. But you can see, as we talked about earlier, on the interdependency, there is some compromise you might have to make if you want to go to a larger field of view. So broad compatibility. So we are a diffractive waveguide company. So we work with different types of projector company, projection technology to integrate with our waveguides. So we give customer the flexibility to choose the right solution for them. And these solutions include DLP, LCOS, and micro LED. And it is very important, these days, that customers are looking for projector and to integrate with our waveguides have that very small tempo space right here, so to achieve that like a sunglasses form factor solutions. Large eye box, we talked about earlier, and of course, the eye relief, that will be allow customer to implement a prescription solution into it. So when customer doing these integration, one thing is really important is about how to bring out the best performance when you are integrating the projector with the waveguides. And of course, we work closely with all our partners and to make sure all the integration brings out the best efficiency and best mechanical design that brings out all the best efficiency when you're doing the integration. And we have this integration information that we share with our partner, developer, and makers, and to ensure they bring the best out of performance and efficiency. So quickly just give everybody an overlook on where we are. It sounds so simple when I first started, say, hey, we are a diffractive waveguide company, but we really do everything from design, from manufacturing. Of course, these including, so these things are not step by step, but these are all the things we do. Of course, we do design for manufacturing, verification and validation of product, and mass production, metrology, and of course, all the way to supply chain management. Because we are a waveguide company, sometimes customers want to consign the products, sometimes they want to deliver to their factory directly, sometimes they want to deliver to their manufacturer. So we need to have we have to do supply chain management to meet customer demands. So what does it take? And we are a waveguide company, and our focus is on waveguide, but our mission is, of course, to deliver the consumer glasses to the market. That means we need to work with an ecosystem partner. We need to work close with them to bring that solution to the market. Whether it's waveguide supply partners in the ecosystem, where it's projector partners. As you can see the picture here, it's just done with our projector partner, Evergon. This was announced during AWUSA. This is a reference design, and you can see it at our booth. But also, I'm very proud to share the information that currently we are working with the major consumer electronic ODM manufacturers on prototype designs. And some of these prototype designs will give everybody the perspective of a full augmented reality glasses experience. And these will be disclosed as more towards the end of the year. And by the end of the year, we have more information to share with everybody on these prototype designs. So it's very important for us just work with the ecosystem partners to really bring out the solution. So here's just a list of our partners and collaborations. These partners and collaborations starting from whether it's material, and whether it's ecosystem technology, projection, or manufacture. And for us, we continue to expand that manufacturing, expand the partners' collaborations to ensure we bring more feasible solution to the market. So I'd like to close this presentation by sharing that to really understand about waveguide goes beyond attending presentation, reading the spec, watching YouTubers. It really experience waveguide. You got to see it for yourself. You got to really put your eyes and look into it to give you that experience. What is natural? What is the eye box? What is the user experience? What's the form factor look like? And I invite you, for who haven't had a chance to visit our booth, to have that experience. Thank you very much. Enjoy the rest of the show.